What is LC oscillation? LC oscillation. When a capacitor is connected in series to an inductor, it is called a LC circuit. This is a capacitor and this is a inductor. So when a capacitor is connected in series to a inductor, it is called LC circuit. And a LC circuit gives you electrical oscillation. That is why it is called LC oscillation. How a LC circuit gives electrical oscillation? First, what we do? We charge the capacitor. We charge the capacitor by means of some external source. When the capacitor is fully charged, it discharges through the inductor. During discharge, current will flow in the circuit. Current will flow through the inductor, as a result of which magnetic field will be produced. In the inductor, magnetic field will be produced. So when the capacitor gets fully discharged, suppose the capacitor gets fully discharged, what will happen? Complete magnetic field will be produced in the inductor. Then what will happen? This magnetic field produces an induced EMF, and the induced EMF produced a electrical current in opposite direction, in this direction. So again the capacitor gets charged, but here in this case the capacitor, charging of the capacitor will be opposite as in the previous case. The charging of the capacitor will be like this. This side will be positive and this side will be negative. So now the inductor will charge the capacitor. Again what will happen? The capacitor get discharged. When the capacitor get discharged, it induces the magnetic field in the inductor, and the direction of current now will be in this direction. Current direction will be in this direction. So the capacitor will get fully discharged. Then what will happen? This inductor again produces current, but in the opposite way, and the capacitor again starts charging, this side becoming positive and this side becoming negative. In this way, electrical oscillation continues in the LC circuit. That is why it is called LC oscillation. And what is important in LC oscillation is the frequency of oscillation. You have to find out what will be the frequency of oscillation, and the frequency of oscillation is equal to 1 by twice pi square root of LC. L is the inductance of the inductor and C is the capacitance of the capacitor. You can find out the frequency of oscillation by two methods. One is your by voltage drop method. What happens in voltage drop method? The voltage drop across the capacitor must be equal to the voltage drop across the inductor. Then what will be the voltage drop across the capacitor? The voltage drop across the capacitor is equal to, we know, C equal to Q divided by V. So voltage will be equal to Q divided by C. So voltage drop across the capacitor will be equal to Q divided by C. And what will be the voltage drop across the inductor? Voltage drop across the inductor will be equal to minus L di by dt, derivative of current with respect to time. So since voltage drop across the capacitor is equal to voltage drop across the inductor, So Q divided by C must be equal to minus L di by dt, and that must be equal to minus L. We know I, current I equal to rate of flow of charge dq by dt. So this will be equal to second derivative of charge with respect to time, because I equal to rate of flow of charge. So second derivative of charge with respect to time. So what will be Q divided by LC? Q divided by LC, that will be equal to minus derivative of second derivative of charge with respect to t. If you rearrange the term, this will be equal to second derivative of charge with respect to time plus 1 by LC into Q, that will be equal to 0. Okay, and this equation represents a second order differential equation, and in simple harmonic oscillation, if a body will oscillate simple harmonically, then the equation will be in this form. The equation will be in this form. Okay. We know if a body oscillates, then its equation will be a omega square derivative of second derivative of x with respect to t plus omega square x is equal to 0, and this is called the angular frequency. And if you compare these two equations, then the LC oscillation will be simple harmonic. And what will be the frequency of oscillation? Omega square will be equal to 1 divided by LC. So what will be omega? 1 divided by LC square root. But we know omega is equal to twice by f. Omega is the angular frequency, f is the linear frequency. So 1 divided by twice by f is equal to 1 divided by square root of LC. So what will be f? F will be equal to 1 by twice by 1 divided by square root of LC. This is the frequency of oscillation in LC circuit or LC oscillation. You have to remember this formula. And another method to find out the frequency of oscillation is by the reactance. Okay, the opposition produced by the capacitor. What will be the opposition produced by the capacitor? That is equal to Xc. And what will be the opposition produced by the inductor? That is equal to XL. Okay, the reactance produced by the capacitor must be equal to the reactance produced by the inductor during oscillation. And what will be the value of Xc? That is equal to 1 divided by omega c. And what will be the value of XL? That is equal to omega L. So what will be omega square? That is equal to 1 by LC. So what will be omega? That will be equal to 1 divided by square root of LC. Okay. So in this way, you can also find out the frequency of oscillation of LC circuit. Okay. And this LC circuit is very useful to generate waves. In electrical circuits or whatever wave, electrical wave or electronics wave. That is why it is also called generator. LC circuit is also called generator. So you have to remember this formula. What will be the frequency of oscillation, and you have to remember this circuit or how it oscillates, how LC circuit gives sustained oscillation. Thank you.